The two main categories of electric motors are AC and DC motors. Within each category, there are several common types. Let's start with DC motors. The most basic type of DC motor is the brushed DC motor. Brushed DC motors are characterized by their use of brushes to make electrical contact with the commutator, which reverses the current in the motor windings. This allows the motor to continuously rotate. These motors are relatively simple in design, making them inexpensive to manufacture. They offer high starting torque and are easy to control using variable voltage. However, brushed DC motors have several disadvantages. The brushes wear down over time, requiring periodic replacement. The friction between the brushes and commutator reduces efficiency and generates heat. The commutator and brushes also produce electrical noise, which can interfere with nearby electronic circuits. Due to these limitations, brushed DC motors are typically used in low-cost applications where long life and high efficiency are not critical requirements. Next, let's look at brushless DC motors. Brushless DC motors overcome many of the limitations of brushed DC motors. Instead of using brushes and a commutator, brushless DC motors use electronic commutation. This means that the current in the motor windings is switched electronically based on the position of the rotor. Brushless DC motors offer several advantages over brushed DC motors. They have a longer lifespan because there are no brushes to wear down. They are more efficient because there is no friction between brushes and a commutator. They generate less electrical noise. Brushless DC motors are more complex and expensive than brushed DC motors, but their improved performance and reliability make them suitable for a wide range of applications. These include applications such as electric vehicles, drones, and high-performance appliances. Now, let's discuss AC motors. The most common type of AC motor is the induction motor. Induction motors work by inducing a current in the rotor windings. This current is produced by a rotating magnetic field created by the stator windings. The rotor current then interacts with the magnetic field to produce torque. Induction motors are known for their simple design, reliability, and low cost. They are widely used in industrial applications such as pumps, fans, and compressors. There are two main types of induction motors, squirrel cage and wound rotor. Squirrel cage induction motors are the most common type. They have a simple, robust rotor consisting of conductive bars connected by end rings. Wound rotor induction motors have a more complex rotor with windings connected to slip rings. This allows external resistors to be added to the rotor circuit, which can be used to control the motor's speed and torque. However, they are less efficient than squirrel cage motors and require more maintenance due to the brushes and slip rings. Synchronous motors are another type of AC motor. Synchronous motors operate at a constant speed, which is determined by the frequency of the AC power supply and the number of poles in the motor. Unlike induction motors, synchronous motors require a DC excitation current to create a magnetic field in the rotor. This field locks in with the rotating magnetic field produced by the stator, causing the rotor to rotate at the same speed as the magnetic field. Synchronous motors are more efficient than induction motors, but they are also more complex and expensive. They are typically used in applications where precise speed control is required, such as in generators and some types of industrial machinery. In summary, the most common motor types can be categorized as either AC or DC. DC motors include brushed and brushless types, each with its own strengths and weaknesses. AC motors commonly include induction and synchronous motors, each suited for different application requirements. Understanding the principles and characteristics of these motor types is essential for selecting the right motor for a particular application.